So converting to sheet metal from solid bodies is fairly easy. So we will have a look at some examples here in regards to convert to sheet metal. We can obviously, by thinking a little bit lateral, create a lot of geometry with a simple sort of boss extrude here. So instead of doing a base flange and edge flanges and then editing the sketches, we can go in and actually use a solid and then convert that to sheet metal. So we will just go forward here. So convert to sheet metal obviously allows us to pick a thickness here, for example. I'll just give that 3 mil. And we can pick edges on the solid model to define our bends. And then we can choose whether we want to reverse the thickness on the inside or the outside here, all depending. There's a lot of other settings in here we can have a look at a little bit later on a different model. It's possible to just set the thickness, or you can use your gauge tables if you desire so. And then it's just a matter of clicking some buttons, tick OK, and we've got a sheet metal part, like so. Since it's now a sheet metal part, we can obviously then add edge flanges, so we can continue modeling on this with conventional sheet metal modeling methods, and obviously that flattens as well. Another example, so again I had an example here. You might have seen it already, but you didn't have any sound, so again my apologies for that. This is just a standard multi-body part to solids in it. So again, from concepting perspective, it's pretty practical to be able to do this. So we can quickly go in and convert that as well. So this is basically pipe clamp. So let's just make that a little bit fatter there. And off we go. We've got a bracket for that. And consequently, we can just continue here and make a bit of a modification to this, just putting some holes in here like so. This time it went a little bit better. Extruded cut, and here you sometimes have to sort of select under the feature scope what you actually want to affect. In this case I only want to affect my sheet metal part, and off you go. We've now got a pipe clamp, and naturally that flattens out beautifully. Other things you can convert, this is a sheet metal part. Oh, rubbish. It's a surface part, obviously. So the surfaces can be converted to sheet metal as well, and that actually gives you a little bit more flexibility in regards to modeling in multi-body. So here it's again just a matter of going into convert to sheet metal. Pick the bend, and off we go. Very simple. So that surface could have been extracted from a master model, for example, which you might want to convert. Another example, we've got this little tank here. So obviously we're talking multi-body. Up till now we've just done single bodies. So we can use a body to make multi-body sheet metal parts. So again, I'm going from a normal extrude. I've split the face on the top here for a lid or a solenoid or whatever. And here we can then go in and obviously set that as well. The trick here is to keep the body. So I want to make multiple sheet metal parts with this, so I want to keep the body for the next part of this. I'm just going to whack that in here, and you'll see when I go OK, the solid body will actually stay in there, and we can move on and do another convert to sheet metal and pick the edges for that. You can control them individually as well, so if you need multiple thicknesses, we can go in and basically override the default parameters here and say that the bottom sheet here is a 2.5 mil sheet. And for the last sheet metal body you put in there, it's practical to obviously untick the keep body tick box here, so it gets consumed, and off we go. We now got 2 sheet metal bodies in there. We can flatten and obviously detail out, or start to detail out, like so. Okay, let's move on to the next. So there's not really any limits in regards to number of bodies when using convert to sheet metal. We can sort of go in and pick and choose. Sequence is important when you work with bends and converting to sheet metal, so it sort of has to be connected when you pick the edges. And you can see sometimes you don't get a preview until you get the last bend put in here. Again, we can keep the body and go on. Now this also leans toward if it's all plate work, for example, so we can do multiple. Let's say this is made out of 10 mil plate. We can just go in and basically add them in as we go and keep the body. I'm just going to reverse this. Again, I need to override here, and then we can go in and actually have individual sheet metal or plate work, if you like, just straight off the bat. We'll have a look at another example here. Another interesting one here is this lobster tail, or kind of a lobster tail, so it's a bit of pipe work. This was actually made with a weldman as well. So a simple sketch, a simple sketch where I've got the path for the weldman profile, and that same sketch I used to cut these individual bodies, so we've got a bit of a gap. Now you will see with convert to sheet metal that this does not really work. It wants a planar face or flat face. I've seen a few examples where attempts are fruitless, obviously, because you can only do straight or flat items here. So the tip here is to use insert bends instead, and you can then pick an edge of the body, and we can tick OK to that, and we will then have, we'll just toggle the flat display here. We'll then have the flat pattern here. Naturally that works for all of them, so you can have them all in one part, and then you can detail them out later on when we get to that. So again, we can flatten that and have a part ready to rock and roll, literally. Okay, so yeah, so it's no limitation really to what type of body it is. We can sort of convert most of things from solids into sheet metal, so it's only your imagination that sort of sets the limits. I'm just going to have a look at another example. So this is just a typical example of what you can do. So this is just an enclosure. It started out with a boss extrude, and then obviously we did a convert and another convert, and then we basically did all the standard operation you can use with sheet metal features, and putting on edge flanges, cut extrudes. The beauty about this is obviously that everything sort of stays in check. You don't have to worry about assembly mates and hole alignments and whatnot. If you move a hole, obviously that's going to ripple through to both components, and you will see that if we isolate this that we've got all the holes intact, everything lines up, and naturally this flattens as well. We'll just toggle a flat display here to have a look, like so. Okay. A good one here is the alternative to a weldment profile. So you might have seen it, but you probably didn't hear the sound, so I'll repeat this as well. So this particular part is just a weldment profile. So you see it's the tapered flange channel, and there's obviously some cuts in there with the holes. So if you want an alternative to this, you might want to have a bent up profile, and again we can use convert to sheet metal, and the beauty about this is obviously that we can keep all the holes intact. I'm just going to reverse that thickness, maybe reduce it a bit to maybe 5 mil, 5 mil radius. Whoops, I forgot something here obviously, and that's that little keep body functionality there. I don't really want to keep that in my convert. And we have got a plate that can be bent up, good alternative maybe to our drawn profile. Very good. Okay, we will have a look at a more complex sort of case. So I'm just going to open up another file here. So this is basically the one I want to work with today. This is in fact a part we've used back in 2011 in the What's New. So I'm just going to basically start from scratch here. So I'm just going to delete all these things out. Like so. So simple extrusion with a couple of cuts. There's some bosses in here, there's some clearance holes, so the whole thing is set up, and we obviously want to change this so it's a sheet metal part and then make some drawings of it. So again, it's a matter of using convert to sheet metal. I'm just going to use a 3 mil with a 2 mil radius. Now you can see in this particular component that there's pre-made bends, if you can call it that, as such here, and they could have different radiuses, and the system is smart enough to pick up on that. So I'll just do the base plate first here, and I'm just going to tell it to collect all the bends. Obviously this is a little bit thick, so we might want to change that again, so I'll make that 3 mil. So it basically overrides the radius here by collecting the bends, and consequently you will get what the geometry tells the sheet metal to do. I'm just going to reverse the thickness here. And again, I forgot to tick my little box, so we can always edit the feature and keep the body here. That works well. Now one conundrum is obviously if you've got, for example, these sides here, and I actually want these to be in halfway, so they have to sit 1.5 mil offset because I use 3 mil sheets. Currently it's not really out of the box possible, but what one can do is offset the surfaces and then use the surfaces to convert to sheet metal. So you can rely on multiple bodies, surface bodies or solid bodies in the part, so you can convert them together as such. So here I'm just going to offset this surface here. I'm going to reverse that so it sits inside with an offset of 1.5 millimeters. And the same on the other side here. So again, an offset surface, 1.5 millimeters offset, and they now sit in there. So I'm just going to show you. I'm just going to hide that for now, so you can see there's two surfaces sitting in there now. So, and we will work with that. So again, we can do a convert to sheet metal here, and the trick here is naturally to go in and pick this surface now, and that makes it then possible to sort of go halfway, so you can sort of manipulate the model and get the placement of the sheets in the correct spots in that way. We'll just repeat that for the other side here as well. I'm just going to select the surface in there and get them in where they belong, and we will tick OK to that. So I obviously now got 3 sheet metal bodies in there. I'm just gonna make sure that my cut list is updated here, and you can see we sort of get them in there. Now if you've got 2 opposites like that and you want to combine them, it's relatively easy. You can actually do that with an edge flange. You might know this, but if you don't, there's actually an option for that. So I can use my edge flange here and basically go from 1, and then for the flange length here, in this section here, I can go in and up to edge and merge, and I can then go in and pick the opposite edge here. Oh, hang on, what happened here? There you go. So, and again we can sort of manipulate the offset here as well. So obviously we can do all the standard stuff. So if we want that halfway in here, there's actually an offset here, an option to offset it. 1.5 millimeter, maybe that should do the trick. And here we have it. So that sits in there nice and easy. And we might want to break corners so it looks tidy here as well. So we'll just do a 4.5 millimeters corner, and off we go. And you'll see in the cut list that obviously this now got merged. We will just check if it flattens. It should. That all flattens. It's a good practice to just quickly check whether we've got problems or not. And we can continue with that. So I'm just going to show my body here again. Like so. I'm just going to put a lid on this. And again, I'm going to use convert to sheet metal. This time I'm going to untick the keep body because it's the last body I'm going to convert. Again, I'm going to collect all the bends. You can see they highlight in the use interface here. And all we have to do is tick OK. Whoops, I think it's probably the thickness here again. We can naturally, with this, I mentioned this before I think, but we can obviously run different material thicknesses as well. So we'll just pop that in here, and I'm finished with it, so I don't want to keep the body. And we might want to polish that off with an edge flange here at the back. And in this case, I'm just going to use up to vertex. And it's all good. Again, test for functionality. And that all seems sweet. So we're just going to hide these 2 surface bodies. And we are ready to rock and roll in essence. So we will have a bit of a look at a couple of options here. One of them is if you've got a multi-body sheet metal part, is that you can straight off the bat export all the flat patterns out in one hit. So when we export DXF, DWG, we obviously got some options in here. One is to export to separate files, so we can do that. And when we save here, I can go in and actually stick these flat patterns in as we go. We'll just take two of them in this case. Let's take all three of them. And I can obviously choose whether I just want the geometry and bent lines and all that sort of stuff. I can put them in a single file or a separate file here. And when we go through the export dialog, you will see that we now got all the sheet metal parts ready to save out as DXFs. And off we go. We'll have a bit of a look at the cut lists. When I work with cut lists, I like to sort of rename things, so I can go in and say, okay, this is a bottom brace. This is a top brace. And let's just call that main body, like so. And it actually helps when we get to the cut list itself, so it's easier to identify in regards to the cut lists, what's actually belonging to what. Bends, so we've got all this information now in the cut list in regards to bounding box area blank, and so on and so forth. So it's pretty comprehensive now. The only thing it doesn't do is obviously with the descriptions here, but that makes it easy if you've renamed the cut list folders here, that we can sort of replicate that. Top brace, bottom brace, and obviously our main body, like so. So that sort of make more sense. In the cut list itself, you can put in other custom properties as such. So we can put in the part number. We might put in material. Oh, it's actually already in there, so don't do that. And part number, we can obviously start to put in numbers here, or we can go to the properties summary here. We just have to, I believe, save this first. So we're just going to go out and in again. So the properties summary should actually show us the part number here now, and I can now go 4, 5, 6. So we're just putting some random numbers in here, and off we go. So for the properties themselves, it sort of piggybacks off the properties list file, and you can always put other things in here as well. So we can add other custom properties on the fly as such, and then we can sort of tap into it via this dialog as well. So in essence, you should look at this as an assembly as such. So consequently, the custom properties on the top level would be as you normally do with an assembly. It just makes it easier to manage. There is some options in regards to saving bodies out, and also if you want to tap into some of the other properties in a standalone part, we can insert this into a new part. And we can transfer the cut list properties to either the cut list properties in the split part, or to the file properties, which is your custom properties. And then it's just a matter of going OK to that. And when we have a look at that, you will see that now it's a solid body with a reference back. So obviously the part we just came from is not a master model as such. So here you will see that all the properties from the cut list has been deployed into the body itself instead, so it's linked to the parent. So the only place it's going to change, or you can change this, is basically in the parent part as such. Just close that again. Okay, another option you've got for multibody parts, this is not just multibody sheet metal, but it's also any multibody part, is that we can explode it now. It's not obvious, so where you find it is actually under the configuration, where we can put in new exploded view. And then we can sort of go in and manipulate that a little bit. We're just gonna align up to this, drag it up, maybe this one as well. We're just going to align it to this face so they drag them out, so we can drag them out sort of uniformly. So now we've obviously got an exploded view in there. We can explode and collapse. Limitation is you cannot animate it just like in an assembly. It is a static explode as such. Like so. And we will go in and have a look at drawings. So we're just going to have a crack at that. So we will make a new drawing from this. And in this case, I'm just going to whack in an isometric exploded view. And we will insert a cut list. So this is obviously now our bill of material as such. So a Weldman cut list, we'll stick that onto that. And out of the box, it doesn't really give us much in regards to sheet metal, because obviously it's meant to do Weldman's. It's a standard cut list as such. So you can change these obviously by picking the cut list properties here. You can use cut list names if you want to tap into the cut list name instead. Again, we've got duplicates obviously because I call them the same. Cut list item property, so I can go in and change that. Say I do not really want the length here. Sorry, I'm on the wrong box. So I don't want the length, I actually want my thickness. So sheet metal thickness here, we can just delete that out and just call it thickness. We can add in other items here by inserting columns. And for this one here, I might gonna put it in my part number. And all we basically have to do now is balloon it. I'll just auto balloon this view here. And off we go. So that's sort of half of the thing. So individual sheet metal bodies, obviously you would like maybe the flat pattern out on an individual sheet, and it's technically just a matter of adding another sheet, and then use your just going to go back to the part first. There is a little bug here, so if you want to do single body views, make sure that you actually take it out of the exploded view here, and when we then return to the drawing, we can then get started. So in the view layout we can use a model view, and obviously we pick our part we want to model. And we now got an option here, select bodies, and I can go in and I'll just select the main body here. And down the bottom here you actually get an option for flat pattern for the more views, and there you have it. You've got the flat pattern on the sheet. I've been looking for a way to get cut list properties deployed into the sheet format as such, but currently it's not possible. Not that I know of anyway. If any of you guys know of a way, please let me know. It's always good to be enlightened that way. So obviously that way we can both do the flat patterns straight out of the bat, but we can naturally do normal views as well. So we can go in and make simple projected views here, and all we have to do is naturally line them up. Back to the custom properties. So what I've found though, you can attach cut list information to a node. So it actually works in this way. You can make a standard node. You have to attach it to the part itself. We can go in and change link to property here, and it would have to be the component to which the annotation is attached. And then I can go in and pick, for example, part number, and we've got it there. So I did a little bit of a workaround here. So I created a node tapping into multiple items in the cut list and put it into my library. So it's basically just detaching it and save it into your design library, and when you drag it onto the view, it will then deploy the information automatically. So all depending on what information you want to derive out of the cut list properties, you can obviously do that this way instead. So that makes it nice and easy to at least add the information to the shade whereof you have perhaps a flat pattern. So that's a little bit about a few tips and tricks in regards to drawings and properties. We could obviously finish this little fella off here now by adding more shades, and then go in and reiterate this. So it's model view. We'll go next here. We will select the body. I might just pick this top one this time. And for insertion of the view, this is where you go down to this area in your property manager, and then choose a flat pattern, and then we can add them in just like that. And again, if you set up a node linked to cut list properties, you just drag it into the view and place your node. So now we should have a couple of different sheets here ready to go. Okay, so that's basically a quick run through Multibody and especially converting to sheet metal. I will just check you out and see if you've got any questions whatsoever. You're obviously welcome to put your hand up. So we've got Glenn. I'll just open it up for you now, Glenn. So have you got a question, Glenn? Hello? Okay. We've got Wayne. Wayne, I've opened up your microphone. Have you got any questions? Okay. What about Fraser? Chris. It sort of jumps around a little bit here on my screen. Hang on a sec, Fraser. I'll open up your microphone. Hello. Fraser, are you there?
Yeah, hello. Can you hear me?
Yeah, I can hear you.
I was just wondering if you could show again how to set up that note.
Oh, yes, of course I can. So I'm just going to mute you again. There's a bit of noise in the background there. So with the note, so basically I obviously tapped into these different custom properties here. So the trick is here to create an annotation node and actually initially attach it. So you have to put the leader on. And then I can say, okay, I want to tap into description, say. And with a space, I go over here to the left-hand side and link to property. And now I can actually tap into component to which the annotation is attached. And we can then go in and say, okay, I want my description. And then it's basically just continuing here. So I could go in and put something else in here. Let's just tap into something else, maybe part number, like so. And again, I'm going to use my link to properties, component to which the annotation is attached. We can go in and put in, let's just call that part number. We've got part number here. And that's fine and good. Obviously, that's still attached here. So to save it in so you can reuse it, basically what I did was I made it no leader first, and then you park on the node, and then you save the node into your design library. So park on it, so it's active. I'm just going to drag that out to make sure I don't pick anything else here. And add to library. Let's just call that new node. I'm just going to whack it straight into the design library on top level here. You can do that for any custom properties in essence, but you will see now when I drag that onto the view of the body that it will deploy the information. So I hope that answered your questions. I've got Chris Ryan as well. Chris, are you there?
Yeah. Yes, I am. Can you hear me?
Yes, I can hear you.
Thanks. Yeah, I typed my question in. I don't know if you could see that, but it seems to me this is a problem I've had for a long time. It seems like such a limitation that you can't have your cut list properties display into your title block like you would in the other part. So it seems that there are so many advantages doing multi-body sheet metal parts, but you can't do the right drawings. And then, but if you do the assembly, you can do the drawings, but you have all these other associated problems. Is this going to be fixed soon, do you think? Because it seems to have been a problem for a long time.
Yeah, I believe it's probably something that's going to come eventually. There's I had a bit of a look, and there's a multitude of enhancements requests at SOLIDWORKS in regards to this particular problem, and obviously the workaround is to do what I just did here with the nodes, which is a little bit labor intensive, I would assume, but you could have multiple nodes and basically drag them into the fields, I suppose. The only downside is because they attach to a view, if you move the view around, you have to readjust all the nodes again. So that it does pose a problem. I'm assuming that this will be fixed eventually, because there's been a lot of enhancements since 2011 in regards to both cut lists in general, but also the sheet metal modeling in particular. So yeah, but I will make a note of your name and I will let you know when it's fixed.
Thank you, I appreciate that. Yeah,
not
I can't wait till it is.
Yeah, that'll be good. Okay, so we had Chris. See if there's other hands up here. Chris is good. So if there's any other, hang on a sec, I can see there might be some other questions. So Okay. Yeah, that was just regarding my stuff up this morning. So again, I must apologize for the hiccup. There's too many buttons to press when we run these webinars, and I obviously forgot to press one. So I hope you enjoyed this session. Whoops, I'm just gonna go to my final page here. So thank you very much for attending.